All right, I'll go ahead and get started. Sorry about that. All right, so where we left up, so first off, remember you do have an exam this Friday in your labs, and also apparently I found the microphone, so you know. So does this help at all, or is it worse? I don't know how. Okay, I don't know how hard it was to hear me back there to begin with, so we'll try this out. All right, so basically it's going to cover everything, including the for loops that we've learned up till now. And right now what we're going to do is that we are going to review a lot of the stuff we learned using graphics. Now, I don't know how many of you looked at the practice exam yet, right? I posted that online, right? So so the practice exam is a good facsimile of it. You know, it's a good amount. It covers a good amount of the topics that will be covered on the exam. And be sure to, and I've attached additional practice problems on the back, which you might find helpful, okay, to practice on. Okay, and you are allowed to bring in a sheet of paper front and back for notes. So you're allowed to have a cheat sheet if that makes you feel better, but hopefully you shouldn't need it. Okay, so what we're doing today is that we're learning about how to do graphics in Java. We got started with this for the last 20 minutes of last class, so let me review here. We're learning about 3 different classes. We've got the drawing panel, which is something that the authors provided and wrote. We take a look at it over here. We see that basically it's like a couple thousand lines long, obviously, and it deals with stuff that I don't really want to get into, and I don't think I could get into. But the end result is through a concept of what we call encapsulation. It means that basically I don't really need to know what goes on in it. I just need to know what methods I care about and call them. And I'll show you the methods I care about. Then we have this panel.getGraphics, which we can think of as our. You can either think of it as the metaphor they use that this is our pen for drawing stuff. I personally think of it as the canvas that we draw stuff on, but the metaphor they use is that the graphics is the pen with which we draw stuff. Okay, on a panel of some stuff. And then we can specify colors, which we'll play with today. So what we do is all we have to do. So in order to get this program, by the way, and get this on your computer, you got to open up Firefox. You've got to go to the course website, Building Java Programs, right? And that'll bring, that's buildingjavaprograms.com. So in order to use this panel, or the drawing panel, you'll have to go into Supplements, and click and download either on this if you're using Java 8, or if you're not using Java 8 or later, use this one. Download this file and put it into the same project that you have your class in. Like over here, I've got the drawing panel and graphics example in the same package over there. So it will need to exist. Yes?
So we can download it from a website?
Yes, from this website over here, buildingjavaprograms.com. So if you want to use that and follow along. Otherwise, you can just from buildingjavaprograms.com, click on Supplements, and you'll be able to get it. All right. And the main reason we're going to use the drawing panel, again, that's not really something we care about too much in because what we're really going to do with it is use that to easily get access to a graphics object, which they like to refer to as like a paintbrush, which we can use to draw objects and shapes. So basically to get started with graphics, we're going to first just learn 2 calls. The first is we create a drawing panel, and it creates a new drawing panel with a width and height of a certain amount of the specified amount. So if we go over here, so I didn't specify anything, so let's see what it does. So I didn't pass any parameters into this one. and it just draws one of this size. But if I were to give it parameters, I want it to be like, say, 800 pixels by 800 pixels. Then it gets pretty large. Let's see, zoom out, zoom normal. So that's pretty large. Surprised that that's actually 800 by 800. But for right now, I'm just going to let it be default. Now, when it comes to creating, so this creates a drawing panel, and it allows me to essentially I can manipulate the pixels inside of here. Now, what is a pixel? Well, your computer's screen is made up of pixels, all right, which are these little. I mean, it was easier to see with when laptop displays were less high resolution, but if you're working with something that has like something closer to a 768 horizontal display, sorry, vertical, right? Then you will be able to see pretty individual pixels if you get in really close. And same if you have a 1080p, if you get really close to your screen, you should be able to see maybe some individual pixels. But with the really high resolution screens, not so much these days. Okay. The bigger the screen, the easier it is to see. So, I mean physically bigger. So a pixel really is just basically a small, these days are just small, a lot of them are LEDs, which means they're light emitting diodes, which means they basically have 3 lights in them. But at the end of the day, it doesn't really matter the technology. Every color on your computer is basically, and this is a lot because we've gotten better at displaying colors, but colors are essentially some combination of 3 numbers: the amount of red, the amount of green, and the amount of blue mixed in there. And it turns out that that also is a lie, because what one person says is this much green on this screen is actually not necessarily representative of the green you might actually see in real life when you print it. So it actually ends up being very complicated, and it's like if you're doing graphics design, it's really important to have something with a lot of color accuracy. We don't have to worry about any of that, though. That's just an aside to know that basically what you see on your screen might appear different on somebody else's screen, just a bit in terms of color. Okay? So next thing we have to do is generate our quote-unquote paintbrush, which is that we call this method panel.getGraphics. And with these 2 calls, we're essentially now in standard Java stuff. We've got standard stuff that the Java library provides. So 2 calls, I was able to bypass a whole lot of messy calls that if I didn't use them, my code would look something more along the lines of what I did in data structures, for which was, let's see. Oh, yeah, it's over here. And without these calls, it ends up looking something like this, with a weird extends JFrame, which isn't too much more, but I wanted to make it as simple as possible. Again. So now what can we do with this? Well, let's go ahead and start by drawing a line. So GE is our graphics, and then we can press dot and see what we have. So draw line, and it takes in 4 arguments. Draws a line using the current color between the points x1 and y1 and x2 and y2 in the graphics contents coordinate system. Okay, so this is just like drawing a line like in a coordinate plane, right? There's going to be nothing unexpected about the way this works, right? Although if you remember from last time, if I'm going from 0, 0 to, so I'm going to draw a line from 0, 0, from the origin, 0, 0, to 50, 50, right? And if you didn't watch last Wednesday's lecture, if you don't remember too much, then you might be thinking, okay, it's going to go from, let's see, well, this is a coordinate plane, right? So it's going to go, the line's going to go from the origin to 50, 50, right over here, right? And that's what you might be thinking if you didn't watch the lecture from last time. It goes from here to here. So this point, and actually on the bottom it has like it has a counter over here, you know, at the bottom of that window saying, you know, where my mouse is currently pointing. And it says that this area is around, this is 50-50. And this is just the quirk of the computer, computer systems and the way we program them, and it makes sense when we get into arrays. That we don't work in quadrant 1 right over here, right? Each of these are different quadrants, we say. So first off, we don't have to consider like negatives or anything like that. We just have to consider an entire quadrant, but we work in this quadrant over here, where we consider 0, 0 to be the top left of my screen. Okay? And then this is the x-axis, and then the y-axis goes down. Why? Because if I were to make a guess, it has to do with the fact that with matrices, right? When we deal, if you remember matrices from your mathematics, right? Let me just draw a basic identity, write a basic identity matrix. So 1's on the diagonal, a whole bunch of zeros, right? And let me get the camera wasn't getting that. Oh well, it's not too important. But the idea here is that, you'd say that this is the first row, this is the second row, this is the third row, right? This is the first column, the second column, and the third column, right? So, and that's allowed to just happen. And when we think of arrays, we think of them in the exact same way. And so this just happens to make sure we don't have to switch our modes of thinking when we're talking about graphics. That's my guess. I'd love to hear if anybody knows more about graphics than I do, which is basically probably every other programmer on Earth, what they would like to say. But we can draw a line like that. Also notice I didn't specify a color, so the default color is black, just like the original Model T, right? You can get any color you want, so long as it's black. So if I want it to be a different color, I say g.set graphics. Sorry, set color. And now here, color is a class, just like math, right? And I can interact it this way, where it has just some default variables stored inside of it. These are public final variables just stored inside of the color class, okay? So they're already predetermined for you, like black. Let's go ahead and do magenta. That sounds fun, okay? So I just simply say color.magenta, and I run it, and it comes out, I guess that's magenta. So, right, and if I hover over it, it says that its red value is 255, it has no green in it, and its blue value is 255. All right, so let's explore a bit with colors. If I wanted to create a new color that nobody else, that's not specified, I say I want a new color, okay? And this generates a new color, and it takes in 3 arguments, okay? It takes in 3 integers specifically, from 0 to 255. So let's go ahead and start with 0, 0, and 0, okay? Set color to a new color with 0, 0, 0. And that means I want 0 red, 0 white, and 0 red, 0 blue, and 0 green. Okay? Or, well, green, then blue. And 0, 0, 0 corresponds to this, let's see, as black. Whereas 255, 255, and 255 corresponds to white. This is because there's different schemes for generating colors, whether you think adding or subtractive. I don't know which this one is. But the idea here is that so the colors get brighter by adding more of them. And so if I add them all in evenly to the maximum, then I'm going to generate something white. So if I do 255, 255, and 255, I got a completely white color there. Okay, cool. Let's go ahead and try maybe something like 100, 100, and 100. They don't all have to be even. I'm going to start switching them up a bit. That produces a slightly less dark black. So what if I put in more green? So 200. It becomes a greenish color, right? So you can specify and you can mix and match with colors. And you can generate basically any color you really want to. If you want to change colors, so say we wanted to Now G dot draw a line from 0, 0 to, well, not 0, 0 to 100. Let's go from 50, 50 to 100, 100. So another diagonal line, just picking up where we left off. Okay. And then we'll do, yeah, we'll go ahead and grab this and say G dot set color to blue. So now we were with our greenish color, now with our bluish, so it goes green to blue, right? Essentially, it's like, essentially you're just giving it directions on what to draw. It's very basic directions. Basically, make a stroke and make another, and make another stroke. So it can be very tedious to draw stuff in this manner, but we have stuff that will aid our advantage. So as I also showed other times, you can create filled up rectangles and filled up ovals just by simply calling fill rectangle and fill oval. Okay. Again, the coordinate system is, well, we've already went over that. So here's what we can do. We've got draw line, draw oval, and draw rectangle. Those do outlines of those, and fill those up with the color. Then there's also draw string. So draw string is our answer for, well, it would really be very annoying to have to draw individual letters, one line at a time, and then that's actually really hard to figure out. So let's not do that. Instead, what we're going to do is that we're going to give it a string, hello, comma, world, and then it says it's at the bottom left. Its bottom left is at XY. So let's go ahead and say it's bottom. So let's say 200. So 200. So let's go ahead and say 300 over and 200 down. So hello world, and give it an exclamation point so it sounds a bit cheery. And we'll go ahead and change it to red. So again, here I'm just setting the color. It's like I'm picking up a red pen and now drawing with the red pen. It generates hello world over there, which is 300 over, and the bottom is 200 down. Okay. So now the other thing to do is, just like paint, you can once you have something down, you can overwrite stuff. So for instance, if I were to draw a rectangle at the origin first, so G dot draw, or let's see, fill rect, and it starts at 0, 0, and then I say how big I want it to be. So let's say I want it to be 100 by 100, so a square that's 100 by 100 pixels. So this would draw a black square first, then it would draw the lines I set up. So see, I've drawn a black square, and then I've got my green in there, and then it's hard to see possibly there, but I can see it on my screen, the blue, right? What I'm saying is that sometimes what you see on your screen isn't what it's going to appear on another screen because just monitors and projectors are built differently. So let me go ahead and maybe change that to a magenta again, all in lowercase this time, and see how that. Yep. So now it's a bit easier to see, I think. So, right, you can draw over something, right? Just because you put something down doesn't mean it has to be what it remains. And this means that basically you can create a canvas for you to work, a smaller canvas for you to work on and do stuff. Right? What if we want to give this an outline? Maybe like something or an outline. We can use the fill rectangle on this one. Set color red. So let's go ahead and go down here and say G dot draw rect. So I'm going to draw a rectangle at the same place, which is 100. 100 wide, and so let's see, actually, say 100 100 wide and 100 high. So I'm drawing a red rectangle, except that it is now going to go around. except I'm not filling it. I am drawing the outline of one. So now I've got red around the border of this. I know it's super exciting right now. This is, but essentially what graphics libraries are is that they basically make all this stuff much easier. So this is what I was talking about. When we execute the same, when we execute multiple commands and two shapes occupy the same pixels, the last one wins, right? The last one is what gets drawn. So let's go ahead and see how to draw a basic car. I'll go ahead and copy it over into here. Car, Control A, Control V. So here, we just need to import all the classes that we're using. So import java.w. I'm going to say java.awt.star to get everything from the abstract window toolkit. So here we're drawing. So let's go ahead and go through the commands first. Okay. So what I'll slowly do is I'll uncomment it out to see, so we can build this step by step, so we can see what happens step by step. So the first thing is panel.setBackground color light gray. So that's new. We haven't tried doing anything to the panel yet. But as you might imagine, this sets the background of the panel to light gray. And here we're making it 200 pixels wide, right? And 100 pixels down, 100 pixels high. So it's a small image over here. Small background, we just set it gray. We could set it black if we wanted to. We could set it to some other color. Okay, now let's go ahead and say go line by line. So graphics.get graphics, so that gets us our pen to work with. So the first thing we want to do is that we set a color black and g.FillRectangle. So that means that we're going to create a rectangle that's full, that's black, and it's going to start at x is equal to 10, so 10 pixels over, and 30 pixels down, and it's going to be 100 wide and 50 pixels tall. So just created this. Doesn't look too much like a car, right? So what next step is to add some wheels to it. So we're going to add red wheels. So what we do is that we set the color to red. And the first thing we do is that let's draw one wheel. So let's go ahead. So fill oval at 20, 70. So we're going to make our oval a circle because circles are just ovals that have basically the same height and width, right? Everything is a radius then. So it's got a diameter of 20, essentially is what we're saying. And it starts at x is equal to 20. And it's going to be at the lower edge of the triangle of this rectangle, which is it's going to start with its top left corner at 70. Wait, circles don't have corners, right? Well, what we're doing is that imagine that there was a rectangle drawn around this circle, and its corner was at 20 and 70. So that's where we'll place and then this circle sat inside of it. I'll show you what I mean. G.draw rect, and I'll just give it the same dimensions: 20, 70, 20, 20. Right, so here, again, the rectangle, notice now that it might be here. Oh, right, I can zoom in. So zoom in. There we go. That helps a whole lot. So right over here is the corner 2070 where we draw the rectangle. And we draw the oval. That's the corner of it. And notice that the circle, we're not specifying, or the oval, we're not specifying the center point. We're specifying this point. So we're imagining that there's a rectangle around, and we're drawing the circle that exists inside of that rectangle. In other words, it touches all four sides of the rectangle, or that we create. In this case, a square. Okay. So now we need to move over, and we want it to be over here. So, so what we do is we kind of calculate where we'd like it to be. So where's the corner over here? So we'd probably like it at the same height. which is 70, right? And then maybe over here for the corner, which would be what they have down there, which is 80. So around over here looks good for creating a corner. And then we'll put our other wheel, as a result, it'll be centered like right over here. So if we uncomment it out, and a lot of this is just figured out by trial and error when you're manipulating stuff with shapes over that. Oh, sorry, that looked like this. So zoom in, right? And that just put our wheels there. So it looks a bit more car shaped, or a bit more maybe box train shaped. So we can add a window maybe over here is the idea. So we'll add a rectangle. So first we're going to create a bluish shade for the window, and it's going to be a small window, 30 pixels by 20 pixels, and it's going to be at its top left corner is going to be at 80 and 40. So run this, and there we've got a bit of a car. So maybe I feel like it's missing something to say it's a car, though. Maybe we should put in bright letters that this is a car, like somewhere right over here. Okay, so let's figure out where to put that. So if I remember correctly, the text goes at the bottom left corner. So let's say we want to start our text here. So let's say 25 and 50 will be this point that my mouse is on. And then we'll put like the company name of what of the car is. So let's call this the luxurious maybe CIS box, because it's not really too much of a car. So draw string. Let's put it at x is equal to 25, 50, and then it needs the argument first of what we're going to draw there. So let's call it the CIS box rover. And maybe we should probably give it something other than that same blue over there. Let's go ahead and maybe just give it a white color. Okay. Oh, well, it's a bit too big for that. Right? CIS box rover, it's a bit too big for the car over there. So unfortunately, when you draw stuff, I have either two solutions: to make this text smaller, or to make this car bigger, and then I have to figure everything out. So drawing stuff like this can be really difficult sometimes. Let's go ahead and just make it smaller, and then we can move on to some actual practice. Okay, so which is drawing, because now we can try drawing with loops, right? We can use the idea here is that we can use your x and y coordinates and your width and height and modify those with counters. So let's take a look at this loop over here that they set up. They've got a panel that they set the background to yellow. So let's go over here, and I'm going to just create a new class called loops. I'll call it loop draw. Okay. So first, what we'll do is that we'll grab this, and we need a drawing panel is equal to new drawing panel. Okay. And then we need graphics G is equal to new. Sorry, we don't need new graphics. We just simply say panel.get graphics to get our graphics. And then we just need to import everything. And I'll just simply replace that with a star, which says import everything from the Abstract Window Toolkit. So over here, first thing we do is we set the background to yellow. And then we use red to draw stuff, because red's going to really be nice and have a nice contrast, okay? On it. So for int I is equal to 1, I is less than or equal to 10, I++. So the values for I are going to be 1 through 10, right? Nothing too exciting here. If it was in a loop, I would just simply be printing out 1 through 10, right? So nothing too exciting there. So let's go ahead and see what we're using. We're using, remember, we've got the x, the y, the width, and the height. So let's take a look at the width and the height. All this means is that the circle is going to be, is that we're creating an oval that's 50 pixels by 50 pixels, meaning we're creating circles that are with a diameter of 50, right? Now over here, we're saying that our ovals are going to start at, with their x coordinate at pixel 100, and their y coordinate at pixel 5. Okay, so it's going to be at 100 across and then 5 down. And that's for the first, but this is in a loop, so we're drawing about 10 of these. And then the first one's going to be at 100 plus 20 times 20, so 20i. So the first one's going to be at, it's going to be 120 over. Second one's going to be 140. Third one's going to be 150, and so on and so forth. So let's go ahead and just draw 3 of these to begin with and run it. And they overlap with each other. Now the reason is because, let's go ahead and actually simplify this a bit first. Let's go ahead and just remove the, we're not going to modify the y coordinate yet, so it's just going to go across. So all the pixels are going to be drawn at, all the circles are going to be drawn at y equals 5. So it's just simply going horizontal right now, right? Each eye moves us 20 across, right? So we start at 120 as our corner. Then we go to 140 as our corner for starting where the circle is. Then we go to 160 starting our corner where we draw the circle. So, and then they just kind of smear together because, again, they're 50 by 50 pixels across. If I instead made them 10 by 10 circles, we'd get smaller dots. All right. So now I can make them also go down by basically adding 20 pixels times I. So now this starts at 25, then goes to 45, and then 55 as then 65 as a corner. And so I can just draw a bunch of circles just like this, and I can basically automate this process. And I can make it as big as I want. Let's go ahead and actually make these, so I can make these steps smaller if I wanted to, and then make the circle smaller. I can also use them to do nested loops, which is really cool over here. So let's say I set the color to blue. Let's go ahead and set the background to its default white. So the idea here is that I'm going to be using the draw string, and it's going to say Java, and each one is going to be located at 40x and 25y, wherever those are. So we've got 4 different x values, which are going to be, so looks like x's are going to be 40, 80, 120, and 160, right? Those are going to be all the values of x. And all the values of y are going to be 1 through 29, so that'd be 25, 50, 75, 100, 125, 150, 175, 200, and 225. So those are all the values for y. And basically this loop, because it's nested, is going to be all those x-y combinations that will draw that string. So we're going to draw it a total of 36 times. And so we draw a lot of Java on the screen. Does that make sense to everybody? Where basically we're using a nested loop to draw, to basically say, okay, how did this work? 4 into x is equal to 1, y is equal to 1. So we're going to do 40 at 25. We're going to print Java. Then this inner loop updated so that y was 2. So we're going to do 40 and 50. Then we're going to do 40 and 75, 40 and 100. Well, that's 100. 40 and 125, 40 and 150, and so on and so forth until we got to the bottom. We're at 225. And then once y was 10, we terminated this inner loop. got to the end of this loop, incremented x to be 2, and so now x, we started at x is equal to 2, y is equal to 1. So that meant that we were drawing at 80 and 25, and then 80 and 50. Making sense? All right. So what if we wanted to kind of just change the color a bit as we were working on this? Can we modify the color as well? Remember, we totally could. So g dot so let's go ahead. So if we remember, we can create a new color by doing this. G dot set color, right? And then we can say new color, okay? And then we had 3 numbers. We provided 0 for red, right? And you got RG for green, and then B, blue. So let's go ahead and like make it vary the amount of blue. Like I could set this to 40, but all I'd be doing is giving the same command over and over again. Blue is equal to, we've got 40 blue in there, which is slightly blue, but not really that blue. Maybe let's go ahead and experiment a bit. 100? That's slightly more blue. What about 200? Blue. That's more blue. And then 255. That's basically about as blue as it gets on our screen. And then what about if I like upped it a bit and said I'd like 1,000 blue? What happens then? It tells me that I can't go above 255 for my blue. So I'm going to keep it at blue. You sure? Can I do 512? It's going to say, no, of course not. Color range. Outside of expected range. Blue, it's too much blue. So 255 is the most blue we can have. So maybe why don't we start with 255 blue, and what we'll do is that maybe we'll make it so it's less blue as we go on. So we'll modify it by maybe we'll say 255 minus. So 255 minus x times 20 plus y times 5. And so now, as you can see, we're getting a bit of a color gradient going on here. We're basically we subtract 20 value from over here, and every time we go down, we subtract another 5. So we start at 255 over here, but now we start at 230, and then this one blue was 225, and this one started at 210. And then, so why don't we make this more dramatic and up this initial value? So maybe 40. So we can totally we can do weird stuff with creating color gradients over here. I don't know if everybody can see that, so let me go ahead and zoom in. There we go. It's a bit harder to see. Maybe if we add some red as we print it out. So, and now what we'll do is that what we'll do is that basically as we go, the further we go down, what we're going to do is now we're going to say the further we go across, the less blue it's going to get, but the more we go down, the more red it's going to get. That doesn't make too much of a difference right now because we aren't really adding a whole lot of red. So let's go ahead and say let's add 30 red as we go down. Oh, again, went too big, right? 30 times 9, what does that give me? 270. So that was too much red. So maybe I need to just be a bit calmer with that. So now, each going across, it gets less blue, right? But as I go down, it gets more red. Does that make sense for everybody? Because the y-coordinate is over here in the red, and the x-coordinate is in the blue. And I'm increasing my redness as y goes up, but I'm decreasing my blue as my X goes up. So, you know, we can do some actual, and that doesn't look like too, it doesn't actually look that bad. It actually looks, you know, like a gradient that you would ask a computer to draw. You know, so that's pretty cool. So we started messing with zero-based loops. In other words, where basically what we do is that we start getting a loop that looks like this, where we start I is equal to 0 and then I is less than, right? Not rather than I is equal to 1, I is less than or equal to. We go I is equal to 0, I is less than. Now, what's nice about this is that so long as you start with 0, or if you start with 1 and do less than or equal, or you start with 0 and do less than, it's going to run the exact same number of times, which is this number over here, so long as you're going plus plus. Although the range will be slightly different. So in this case, i's values are going to be 0 through 5. If it was, 0 through 4. If it was I is equal to 1 and I is less than or equal to 5, it would be 1 through 5. So, and the idea here is that basically starting at 0 often makes that fence posting problem sometimes a little bit easier because you can deal with that a bit more easily. Or in this case, where basically we want to start somewhere, here we want to create a horizontal line of 5 20 by 20 rectangles, starting at pixel 11, 18. And the idea here is that we want to increase x by 20 times each. And if we were starting at I is equal to 1, this equation over here would start our first rectangle 20 pixels too much over, so we'd have to subtract 20 in here. So that would make it a bit much. That would be more than we want to do. So starting at 0 often allows us to draw stuff a bit better. So let's go ahead and say draw something like that. So for int I is equal to 5, int I is equal to 0, I is less than, let's start with their example, 5 plus plus. So here I want to draw 5 rectangles. So g.draw, draw rect, because I don't want them to be filled, I just want them to be outlines. They're going to be, let's say we want them to be 20 by 20, and let's figure out what pixels I want, where I wanted them to start. Maybe at 10 across, but I want them to be pretty far down, so let's say 400 down, okay? And if I run this, 400's out of my screen, so let's go ahead and put that at maybe 300. Okay, so there's my pixel, and it's using the color that I used to draw the last one. Oh, let's go ahead and make them a bit bigger. 60 by 60, right? There we go. So the idea is that I want them to be a line of connected ones. So I can't use the 20 that they were using, right? They're each going to have to be, so if they're all 60 across, then the next one's going to have to be 60 more over, right? And the idea here is that by starting at 0, I can do plus I times 60. And now, as I increases, they're each going to go 60 pixels over. Right? Over here in my loop, I was just drawing 5 circles on top of each other. So the first circle started here. The second circle started 60 more pixels over. The next pixel started 60 over after that. So we started at I times 60, so 10 times I times 60, which was 10, then 70, then 130, and so on and so forth. So what if I want to do more of these, right? So let's go ahead and do I is equal to, so let's go ahead and say I want them to maybe be a bit tiny so I can do a lot of them. So they're all going to be 5 pixels across. So they're going to be 5 by 5 rectangles, and they'll start there, right? Notice how basically I'm moving, how I have a 5 here and a 5 here, so it's a 5 by 5 square, and as a result, I'm going to be moving each of them 5 over. So we've got a little line of 50 circles over there. All right, so how do I add rows? Well, I'll need another for loop. For int j is equal to 0. Oh, and to close these, remember, you got to actually close the window, which I've not been doing. Otherwise, you might end up your computer might start yelling at you because you're eating up a lot of RAM because you have a bunch of Java programs going. So j is equal to 0. J is less than, let's do 10 rows of these. J plus plus. And so now, right, just adding in a loop like that doesn't really change anything, right? Because I'm not using j at all. If you don't use the inner loop, all it's going to do is just going to repeat I'm just repeating, I just drew this figure 10 times over itself, right? I haven't done anything. So I actually have to move, in order to make use of this, I have to like move down 5 pixels every time I advance. So that I'll put j times 5. So every time j goes up, this inner loop goes up, I'll go down 10 pixels. And so now I've got a grid over here. Sorry, 5 pixels over here. That's pretty cool. And if I were to do FillRect, you know, they'd all be one color. So now let's see again, see if we can't play with our colors a bit. G dot set color. So let's go ahead and play with our reds and blues again. So we'll go ahead and leave 0 for green. And so we've got 50 going across. So, sorry, for going across. So why don't we do red going across and blue going in, sorry, let's stick with the scheme where we're going to use blue going, we're going to modify blue as we go down, and we're going to modify red as we go, actually, let's see. Yeah, we're going to modify red as we go down and blue as we go across. Okay? So which variable modifies our circles as we go, our squares as we go? Which variable should we use to go down? J, because that's associated with the y coordinate over here. So we'll do j maybe times 20. And let's make sure our values work. So j's values are going to be 0, 10. So they're going to be 0, 20, and all the way up to 180. So that seems fair. Right? Actually, I could do 25 because they'll go up to, they're not even going to go up to, because if I do this, it's not even going to get there. It's going to get to 175 in that case. Sorry, no, 225. All right, so now, and let's just say I times 5 for our blue value. And now let's see what happens. G dot set color. Oh, right, what were I missing? Was I missing? It's like, it's just 3 parameters. No, you got to put it in a new color. You got to say, this is a new color I'm creating. It's not one of the old colors, not one of the boring old colors, right? And so now if we run this, oh, doesn't that look pretty? Right? So, you know, and this was just simply by playing with the color commands. You've got kind of like an 80s retro movie thing going on over here with the color scheme. So that's pretty cool. So let's see, and what happens if we maybe just increment I plus I times, and let's start moving the j over here. So I times 2 plus j times 2. So here we're messing with the green a bit, and let's see how that changes it. It lightens up a bit. And if we really want to get exciting with these things, we can totally just, if we want to see a bit more in the way of color, let's go ahead and shrink these down to 1. Right? So we're basically making tiny squares over here. Okay, so now that's really tiny. So let's go ahead and, you know, maybe do 100 by, let's go ahead and make 200 of these and 200 by these. So here we're basically messing with 1 pixel boxes over here. So as a result, I think we should probably just do this J, and we'll figure out what to do over here. So oh, it's too big for that, so why don't we go ahead and make the drawing panel maybe something along the lines of 500 by 500. There we go. And so now we've got basically every single pixel in here is a different color. Isn't that cool? I mean, it doesn't look like it, but it actually, well, actually, but what you can notice from what we did previously, the change in colors looks a heck of a lot smoother. It's a lot less blocky in there because you're dealing with 5 by 5 pixels as opposed to 1 by 1 pixels, right? So that's pretty cool. So let's go ahead and look at let's look at a problem that we can do with these kind of things. So let's write a program that draws the following figure. Let's create a panel that's 200 pixels by 150. And basically we want to draw this figure over here. That basically looks like books, one on top of each other. But like the cover of our book where we've got basically a bunch of stairs going up. So our book over here is size 235. Sorry, it's at 2035. It's going to be over here, size 100 by 100. So let's go ahead and just start that. Cyan background, white over here, and then add stairs. Right? So we're going to build. So the easiest way, again, this looks like a complicated figure to build. Well, again, the key is to break it down one piece at a time and build your way up. And it's very easy to see your progress when you're working with these kind of things. So let's go with book. Let's create a main class. Let's grab our drawing panel. And let's go ahead and do awt.star so we don't have to import anything. All right, so the first thing it said, it wanted what pixels? Sorry, what size? 200 and 150. That's easy enough. 200, 150. Boom. Okay, so we've got a window up. That's like halfway there, right? Okay, now we need the book is going to be located at 2035, and it's 100 by 100, and its background is going to be cyan. Okay, so let's just go ahead and draw a cyan square. G dot draw. Right? No, we can't draw. We don't want to draw. We want to fill the rectangle at 2035. I don't know what it was. 100, but I do remember 100 by 100 because those numbers are easy to remember. So it was, yep, 2035. So now we run this and, oh, right, why is it black? Well, we'd never set it to cyan. So G dot set color. And is cyan a color built into there? It is. So let's go ahead and run it. And we've got that over there. Next, it needs a white BJP, building Java programs, at 7055. Okay, that's easy enough to do. We just draw a string there. So, but we got to set it white. So set color. Color dot white G dot draw string BJP, and it said 7055. All right, so all we're missing are the stairs now. All right, view, we've got the BJP, now we just got the stairs. So let's go into the stairs, which looks like the hard part. The stairs are in color red 191, green 118, blue 73. All right, so G.setColor. So now that we're going to draw the stairs, we need new color 191, 118. 191, 118, 73. So that should be the color. That's the color they want their stairs at. And now each stair is 9 pixels tall. The first stair should be 10 pixels wide. Then they should be 20 pixels wide. And then there should be 1 pixel between each square. All right, so let's go ahead and do that. So I need 10 of these things, so it's a for loop. So for int I is equal to 0, I is less than 10, right? Because I want to do 10 of these things. So this loop will run 10 times. G dot draw. Okay, draw. I keep doing 3D rect, but I want rect. And the easiest way I find to start these is that I always just do the first one, which is that it wants the first one to start at, I guess, that corner of the book, which is 20, 35, and it wants it to be 10 pixels tall. Let's see. Keep looking at these things. Each stair is 9 pixels tall. The first stair is 10 wide, then 20 wide. So the width is 10 wide, and then the second one, and each of these are 9 pixels tall. So we run this, and I've got a comma here rather than a semicolon, so that should be fixed. Now run this, and I've got, oh, what did I do over here? I've got an outline. I wanted it all filled out. So I need the fill command, right, instead of draw rect. So fill. Okay. So now I've got this first one, but now I need to create a gap. I need the second one to be, so now I need to change the width. I need the width to go up by 10 each time. So times 10i. Okay. So all that did was just simply draw that across. Great. And then I need, so I guess I need to move them down as well as I draw them. So it says they're 1 pixel, they're 9 high, but they're each going to be 1 pixel apart from the top to bottom. So that means that as they go down, they're also going to, the y coordinate should go down by 10 each time. So now, hey, that looks correct. So all I did is that basically each one starts 10 down, and I got this little blue in between them because they're only 9 high. So each of these basically was only a certain amount, tall. And I was able to do that all with a single for loop. And you'd think because it's in this diagonal command that basically each of these things would be a different, it might be a double nested loop, but basically because each of these, they're growing by the same amount and growing by the same variable amount. And sorry, they're going down by the same variable amount. We only needed a single loop there. So that was pretty cool. Can we draw a bunch of these? Sure. So let's go. So I think I'll go ahead and stop here. But there's one other command I want to show you, which is that we can actually kind of do some basic animation with these by using a command called sleep, which tells the panel to basically sleep for a bit, to go and just, take a break. And so that's using the panel command, so panel.sleep. Okay, and the idea here is that maybe I'm going to tell it, now the time you put in is milliseconds. So I'm going to say 500 milliseconds, which is how much? How much is 500 milliseconds? Come on. Half a second. So half a second between each rectangle being drawn. So let's see what happens now. Oh, look at that. I can do some basic animation now. Let's run it again for all of you who missed that. And I've told it to put exactly half a second between each of those. So if I put, of course, if I put something like this, 5 milliseconds, it's going to be completely like almost, you're not going to notice it, right? Because it moves way too quickly. If I put something along the lines of maybe, let's say, 200 milliseconds, it's going to go really quick. You know, we can notice that speed. And how quickly can I do that? Well, it really depends on your monitor and what your monitor can see. I think my monitor is at 60 hertz, which means it can display 60 changes a second. So long as basically I'm working at below 1/60th of a second, I'll see the changes. So let's go ahead and, so this was right now, I was updating 1/5 of a second. So this would be 1/50th of a second. So it just popped them up, nice and quick like that. But you can use some basic animation using sleep to just see how things work. So that's pretty cool, right? You thought this was just boring drawing shapes. No, you can do some animation just by telling it to put some stops in between that. And what's kind of amazing is that basically graphics libraries, the things that you see on your screen, are basically things that eventually just get translated. They're high-level commands that always just get translated into the basic, change this pixel to this color, move or change all these pixels to these colors right now. And your computer just does that very, very quickly. Even the most intensive games, there might be modeling some weird physics stuff inside, but there's other stuff. What else can we do with these graphics panels? We can erase everything. We can change the height and width. We can save any image, by the way. So if you create something and you're proud of it, you can use panel.save file name to create a file for it. And then, of course, we can sleep it again. There's also something we can do with polygons if you need to ever make arbitrary shapes. So we might get into that at some point. But for right now, this is the basics of graphics. And so let's just use the last 2 minutes to talk about like assignments and stuff. So typically what I do is that I give you an optional assignment this week that if you feel like doing it. So you don't have to do it if this whole week is crazy for you. But I generally try to make this assignment like something fun you can do. So I generally do like basic encryption during this week. And if you do it, it will replace your lowest grade for your assignments. So you can just do an assignment this week that will replace your lowest grade. Otherwise, so this week is completely optional for that. I might decide to do something that might be more graphical based as well, or I'll give you an option. We'll just see how that falls together. All right. With that, sorry that it took so long to get started in class, but we managed to get through everything, and we managed to look at how we can use what we know, which is for loops, to do all this stuff. We'll do some kind of review on Wednesday. So if I don't create a video that goes over the the problems, I will instead go over the problems in class. So